All right, here's a 3D review problem. It's on page 900 of your packet, I think. There's a blank copy. There's also a full copy or a worked out copy in Moodle. It's just called 900 because it's page 900. So it's down here in the in-class notes downloads, and that actually has the problem worked out on it if you want to have a look at that. So this is just a review of 3D because that could be on the final. All right, so what we want to do here, we want to find the force from A to B, the position vector from C to A and A to C, and then the unit vector from A to C. And then we want to find the compression in AC caused by FAB and the moment about C caused by FAB. Let's go through the steps you would go through in 3 dimensions to get that done. All right, so there's just a series of processes here that are 3-dimensional processes. So the first one is to find the force from A to B. So the steps in doing that is the first thing you want to do is find the position vector from A to B. And when you do that, you want to reverse the order. You want to take RB minus RA to start, and that will get you the position vector from A to B. So we had to find the coordinates of A, B, and C. I've got them filled in there. You do that by looking at the dimensions. So for instance, to get from the origin to B, you're going -3 in the X, 11 in the Y, and 4 in the Z. To get to A, you're going 8 in the X and 2 in the Y. And to get to C, you're going 3 in the negative Y direction. Okay. So we take RB minus RA and get RAB, -11, 9, 4. Take the square root of some of the squares to get the length. That would be a distance there in meters, I would presume. Divide that distance into the position vector from A to B. You get a unit vector from A to B, -0.745, 0.610, and 0.271. You then scale that up by the magnitude of the force, which is 400. And that gets you -298, 244, and 108 newtons. So there's the force vector from A to B. All right, now we want to find out some things. So that's this force vector right here. Now what we want to do is get some information about this armature here, whatever this is that it's acting on, okay? So let's find the position vector from C to A. We'll take RA minus RC. We'll get 850. That's from C to A. So from A to C is the negative that. It's -8, -50. Square root of some of the squares gets you the length, 9.43. Divide through by the position vector by the unit vector, by the magnitude, you get the unit vector. That's the unit vector that goes from A to C, -0.848, -0.530, and 0. Okay. All right, now we have position and unit vectors that we need. Now we can find the compression and the moment, okay? So to find the compression, we do a dot product. We dot FAB with UAC. To do a dot product, we take the force vector and the unit position vector from A to C. We multiply the like components together and add up the products. So you take these 3 products here, X component times X component, Y component times Y component, and Z component times Z component. You add them up and you'll get 124 newtons. That's the compression in AC that's caused by force AB. Now to get a moment of the force AB about point C there, you need a position vector from C to A. That's important. It goes from C, where you're taking the moments about, to A, where the force is applied. That's 850. You would then cross that with the force vector, -298, 244, 108. So you just do a cross product. The formula is right on the formula sheet. Here I've got the cross product set up in a 3x3 determinant form. So however you like to calculate cross products, you just need to run through that. So you'd start by taking out the top row, first column, and crossing what's left. 5 times 108 minus 0 times 244. then what you would do is you would cross off or take out the top row, middle column, cross what's left. So that's 8 times 108 minus 0 times negative 298. There's a negative sign in front of the j component there. And then you do the last little bit there. You take out the top row, take out the last column, cross what's left. So 8 times 244, looks like I'm missing a parenthesis there, minus 5 times negative 298. That's the k component, and there's the moment vector. Okay, so that's the moment about C. Okay, last little thing I was wanting to do, or I did on this at the bottom, was just find the resultant of a couple of vectors there. So we got one vector spec'd out by angles, then I just gave you what FAB is, just to kind of go through an example of a resultant there. So to find F1, you take the 300 newtons times the unit vector, which is found by taking the cosine of the 3 angles that the vector makes with the x, y, and z axes. So 300 times each of those unit vector components gets you F1. You would just then add it to FAB, get a resultant vector, take the square root of sum of the squares to get the resultant magnitude, which is 515. So that's a little bit of a run through some 3D functions there, just a review, because I know it's been a while since you've had that.